answer very cleanly. It's easy. Watch. So again, we're talking about side-side angle, or angle side-side. Tee-hee. What happens if I go angle A equals 40 degrees? Side B is still 10, and side A is 8. Now think about that for a second. It's hard to visualize what's going on here, right? But watch. If I have an angle of 40, I got to make it a 40-degree angle and not like a 10-degree angle. So remember, I always create my horizontal here. And I'm going to make a couple of triangles here. This is going to be 10. Okay? Now, do you agree that I probably have a triangle that looks like that? Correct? I could. Ooh, wait, I don't want 8. Sorry, I want 7. Sorry, you guys. Otherwise, I'm going to make a right triangle, and that's just going to be silly. So that's going to be 7, or I could have one. So I'm going to make this angle of 7. All right? And remember, this angle in here is 40 degrees, correct? So this is 10, this is 7. Now here's the problem. Do you see that this was sort of arbitrarily chosen? I could have just as easily taken this 7, and rather than putting it here, I could have put it here. And then I'd have that triangle as opposed to this triangle. That's crazy, isn't it? That's really crazy. Now, the hard part here is recognizing what's really happening. First and foremost, do you notice that the opposite side, the side opposite the 40 degree, is shorter than the other side? So that makes my spidey sense tingle. Now, when everything's said and done here, I'm going to draw this guy much bigger because we're going to solve the whole thing. Okay? So let's draw this thing a little bit bigger and we'll do the whole problem. This right here is called the ambiguous case. Whoa, I lost my stylus. Ambiguous case. And the reason is because it's ambiguous as to which triangle we're solving for. But that's all right. So you ready? I need a 40 degree. I'm going to draw this guy right here. This is going to be 7. This is going to be 10. All right? But I'm also going to draw, this is 10 and this is 40 degrees. But I'm also going to draw, this is 10. This is going to be 7 right here. And this is still going to be 40 degrees. Okay? Now, let's see what happens. How do I solve this? Well, the first rule is don't panic. We're going to solve for the triangle on the left first. And the reason why is because I know this let's label our stuff just so we stay out of our own ways. This is B, this is A, and this, of course, is angle A. I'm going to solve for angle B first. The reason why is I know that law of sines only spits out acute angles. I can't get an obtuse angle. It's impossible. So using law of sines to try and solve for that angle just isn't going to happen. Okay? So I don't panic. I know that sine of B is to side 10 as sine of 40 degrees is to 7, which implies that B, you guys, you're probably hearing some construction going on underneath. I apologize for that, but it is what it is. The inverse sine of 10 sine 40 degrees divided by 7. Now, if you write this up on a test or a quiz, this line, and then give me the number underneath, I'm happy as a pig, all right? So let's see. I'm going to go back to my calculator. What do I got here? I'm going to have the inverse sine of 10 sine 40 divided by 7. And let's see what it gives me. I get approximately a 66 degree angle. So approximately 66.674 degrees. So angle C is easy to solve for, right? I'm going to get 180 minus 40 plus 60 plus 66.674, and I'll just do that on my calculator real quick. 180, because I don't want to bore you guys with that, and then 40 plus 66.674, right? Enter. So I'm going to get angle C is approximately, remember it's rounded, 73.326. Sweet. Now, I'm going to run out of room here, but that's okay. I can do most of this. I know that the sine, I'm going to use law of sines again, sine of C, which is, we just discovered that C is 73.326. So sine of 73.326 is to side C as, again, use sine of 40. We didn't have to round, right? As sine of 40 is to 7, which implies, I'm going to steal some of this because they got a little extra room over there, implies that C equals, what? 7 sine of 73.326 divided by, I'm just doing algebra in my head, you guys, nothing to be afraid of divided by sine 40. So back over here, 7 sine, this is kind of nice because I get to use second answer, right? Second answer, right? And then divided by sine 40. Sine 40. And enter. And this is approximately equal to 10.43. Now, let's make sure this makes sense. Because remember, this guy right here is about 73.326, and this claim is that this is 10.43. Now, remember, always double check your answer. 10.43 is opposite 73 degrees. What did we say that B was? This was 66.674. 10 is opposite, sweet. So 10 is less than 10.43, so it's got to be opposite the angle, which is smaller. 66 is less than 73, right? We agree? And then, of course, our 7 is opposite our 40. Awesome. Now, let's solve. So this is case 1. Let's solve for case 2. I almost wrote cos. Case 2. Law of cosines is next, by the way. How am I going to solve for that angle? That's my biggest challenge, because if I don't have this angle right here, I'm dead. Believe it or not, it's very simple to solve for. I'm going to kick over to the next page so I can draw this bigger, okay? So I'll kick over here. I'm going to draw a badly drawn 40-degree angle. Now, you ready? So I want you to think about this for a sec. And I'll do this in colors, so it'll be nice. Now, before, there's my 7, right? Here's my 7. However, we also know that I can wrap this 7 back, right? That's the coolest part. So I know that this is also 7. Now, what did I just create there with, remember, this angle from the previous page, that angle is the one that I want to solve for, right? And I know that the measure of this angle is 66.674 from my previous work. All right, whoops, let me go back there real quick. Let me show you exactly what I'm talking about. That angle right here, which happens to correspond to this angle right here, is 66.674. What did I just create with this? Let me change the color. Let's go straight on black. This triangle right here is what kind of a triangle? It's got a 7 here, a 7 here. Guess what? It's isosceles. Hopefully you remember from your geometric adventures that isosceles triangles have congruent base angles, which means that this angle must also be 66.674. Well, if this angle is 66.674, what does this angle absolutely have to be? It's got to be 180 minus 66.674. And that always, then I mentioned always works, which is awesome. What is that? Oh, did we do this one before? Yeah. It's 113 point, was 226? No, 326. 326, right? 113.326. So that's the measure of this angle. Now, that always works in the ambiguous case when you have two cases. Once I found this angle right here, and I need this angle, I just do 180 minus the angle that I discovered. So when I stumble back here, what I say, wait, I got to look at that again. Was it 113.326? So this guy right here is 113.326. And now I just have another triangle to solve. I'm going to solve it using this guy. I know that the sine of 113.326 is to 10 is to 10 as sine of 40. Whoa, wait, hold on, back up. Sorry, you guys, I screwed that up. I apologize. I know that the side opposite, the 113.326, is 10. I know that the side opposite, the 40, when I draw these weird little triangles in here, it's easy to get disoriented. I know that 7 is opposite 40. If I want to solve for this side, then I need this angle. But that's easy to solve for. I just go 180 minus, and then what do? 40 degrees plus 113.326 degrees, right? And that gives me this angle. Once I have this angle, I can use the law of sines again to solve for this side. Now, I'm not going to drag you through that. We're going to do a bunch of these in class. You will get practice, I promise. And we've done a ton of law of sines, so I don't want to take up too much of your time doing something that you've already done over and over. But remember, just remember, law of sines, let's just sort of close out the whole lecture. Law of sines can only spit out acute angles. So when you're dealing with obtuse angles, you got to do something cute. No pun intended. All right? You got to be careful in the side-side angle case, always. You're either going to end up with one triangle, two triangles, right, case 1 and case 2, or no triangles, if this guy's not long enough. Other than that, if it's not in the side-side angle way, if it's angle, side angle, you're good to go. It's a piece of cake. All right, I hope you enjoyed the lecture. I'll see you in class. We'll do a bunch of these. Thanks for your time and attention.